Hello students, welcome back to your one and only favorite YouTube channel, Tomachang Tutorial. Myself Kishan Kulum, and today in this video we shall do each and every question of exercise 7.4 from the chapter called Polynomials. Okay, we are doing Polynomials chapter of West Bengal Board of Secondary Education. Now let's begin. Question number 1. Let's read out the instruction of the question first. Let us calculate and write which of the following polynomials will have a factor x plus 1. We have 6 questions. I have just copied question number 1. First we will solve this question and then 2, 3, 4. Okay, let's solve this question. The question is asking us to verify whether x plus 1 is a factor of this expression or not. Okay, we are asked to verify whether x plus 1 is a factor of this expression or not. Are you getting me? Yes. Okay, to check whether x plus 1 is a factor of this expression or not, what we do is we divide this expression by x plus 1, and if the remainder comes 0 means what? This expression is exactly divisible by this expression, isn't it? If the remainder comes 0, then we can say this expression is the factor of this expression. Let me give an example. We have 6 and we have 3. Is 3 a factor of 6 or not? To check this, what we do, we divide 6 by 3. And if the remainder comes 0, like this, 3 2s are 6, isn't it? Remainder comes 0 here. And if the remainder comes 0, we can say 3 is a factor of 6. Similarly, when we divide this expression by x plus 1, if the remainder comes 0, then we can say x plus 1 is the factor of this expression. Okay, now let's begin. 0 of the polynomial x plus 1 equal to 0, isn't it? 0 of the polynomial means x plus 1 equals to 0, or x equals to plus 1, when we take to the right hand side becomes minus 1, isn't it? Let fx equal to 2x cube plus 3x square minus 1. Fx is this. So remainder will be f minus 1, isn't it? F minus 1. So since fx is this, so f minus 1 will be, instead of x we write minus 1, isn't it? This will be the remainder. F minus 1 will be 2 into minus 1 whole cube plus 3 x square means minus 1 whole squared minus 1, isn't it? Equals to 2. Okay, the power is 3, which is odd number. So if the power is odd number, the sign will remain minus, isn't it? Minus into this plus is minus. Okay, now 1 cube means 1 into 1 into 1. 1 multiplied 3 times becomes 1. So that 1 into 2 is 2. So here the power is even number, 2 is an even number. So this sign minus changes to plus. 1 squared, so this plus into plus is plus. So 1 squared is 1, isn't it? 1 into 1 is 1. That 1 into 3 is 3. And here we have minus 1. This minus 2 and this minus 1, they are same sign, number having negative numbers. They are both of them are negative numbers. So minus 2 and minus 1 is minus 3, and this is plus 3. Minus 3 and plus 3 becomes 0. So in this case we got the remainder 0, means x plus 1 means this expression when divided by x plus 1, the remainder we got is 0, isn't it? This means x plus 1 is a factor of 2x cube plus 3x square minus 1. Okay, I hope you got this. Let's go for question number 2. Let's check whether x plus 1 is a factor of this expression or not. This is question number 2. Okay, whether x plus 1 1 is a factor of this expression or not. To check this, we know that 0 of the polynomial x plus 1 should be equal to 0, isn't it? Or x equals to plus 1, when we take to the right hand side becomes minus 1. So let fx equals to x to the power 4 plus x cube minus x square plus 4x plus 5, isn't it? Let fx equal to x to the power 4 plus x cube minus x square plus 4x plus 5. Okay, now if the remainder comes 0, then x plus 1 will be the factor, isn't it? We have seen this in the earlier question. So f minus 1 is the remainder, isn't it? F minus 1 will be the remainder from the remainder theorem. If you have not watched that video, please find the link below in the description. Okay, f minus 1. Since fx is this, f minus 1 will be, instead of x we write minus 1, isn't it? Instead of x we write minus 1. So instead of this x we write minus 1 whole to the power 4 plus x means minus 1 whole cube, isn't it? This is cube minus this minus sign comes here. X means minus 1 whole squared plus 4 into x means minus 1 plus 5. Very, very simple, isn't it? So since the power is even number, the sign minus changes to plus. Okay, 1 to the power 4 means 1 into 1 into 1 into 1. 1 multiplied 4 times becomes 1. So here, since the power is odd number, 3 is the odd number, so this sign will remain minus. Minus into plus becomes minus. 1 cube means 1 multiplied 3 times is 1, isn't it? Now here the power is even number, means the sign will change to plus. Plus into this minus becomes minus. 1 squared means 1 ones are 1. Now plus into minus, minus 4 ones are 4. This is plus 5. Okay. Now let us see the positive numbers. Plus 5 and plus 1, that is plus 6, isn't it? 5 plus 1 is plus 6. Negative numbers are minus 1, minus 1, minus 2. Minus 2 and minus 4 is minus 6. Now plus 6 minus 6 becomes 0. Since in this case also we got the remainder 0, this means x plus 1 exactly divides this. When this expression is divided by x plus 1, there will be no remainder. This means x plus 1 is the factor of this expression, isn't it? Therefore we can say x plus 1 is a factor of this expression, x to the power 4 plus x cube minus x square plus 4x plus 5. Okay, I hope you got this. Now let's go for question number 3. Let's check whether x plus 1 is a factor of this expression or not. What we do is we divide this expression by x plus 1 and see if the remainder comes 0, then we can say x plus 1 is the factor of this expression, isn't it? So 0 of the polynomial x plus 1 equals to 0 or x equals to minus 1, isn't it? Plus 1 we take to the right hand side becomes minus 1. Now let fx equals to 7x cubed plus x squared plus 7x plus 1, isn't it? So remainder will be how much? F minus 1, isn't it? From the remainder theorem we know that f minus 1. So instead of x we write minus 1. 7 into minus 1 whole cubed plus minus 1 whole squared plus 7 into x means minus 1 plus 1. Are you getting me? Yes. Instead of x, since fx is this, so instead of x we write minus 1. Okay. Now since the power is odd number, so the sign will remain minus, isn't it? Minus will remain minus since the power is odd number. So this minus into plus is minus. 1 cubed means 1 into 1 into 1. That is 1. That 1 into this 7 is 1 7 is 7. Now this power is even number, so this sign will change to plus. Now plus into plus becomes plus. 1 square means 1 1 are 1. Now we have here plus into minus is minus, 7 1 are 7, and we have here plus 1. So we have two negative numbers, minus 7, that is minus 14, and two positive numbers, plus 1, that is plus 2. This gives us minus 12, isn't it? So this is minus 12, remainder is minus 12, this is not 0. So you can say x plus 1, therefore x plus 1 is not a factor, factor of 7x cubed plus x square plus 7x plus 1. I hope you got this. If the remainder is not 0, then this will not be the factor of this. Okay, to become a factor, the number should be exactly divisible and the remainder should come 0. Okay, please take the screenshot and we will move to question number 4. Okay, verify whether x plus 1 is the factor of this expression or not. What we do is we divide this expression by x plus 1, and if the remainder comes 0, then we can say x plus 1 is the factor of this expression, isn't it? So to divide this expression by this expression, we do by remainder theorem. So 0 of the polynomial x plus 1 is x plus 1 equal to 0 or x equals to minus 1. Okay, now let fx equal to 3 plus 3x minus 5x cubed minus 5x to the power 4. Now remainder will be f minus 1, isn't it? Remainder will be f minus 1. Instead of x, since fx is this, so instead of x we write minus 1. Okay, wherever we see x we write minus 1. Okay, now 3 plus this 3 is here, instead of this x we write minus 1. Now this comes minus sign, 5, so instead of this x we write minus 1 whole cubed, isn't it? Minus 5, instead of x we write minus 1 whole to the power 4. So this 3 is here, plus into minus is minus, 3 1s are 3. Now since the power is odd number, so this sign will remain minus, this minus into this minus will become plus. So 1 cubed is 1, 1 into 5 is 5. Now since here the power is even number, so the sign will change to plus. This plus into this minus becomes minus. 1 multiplied 4 times is 1, so that 1 into 5 is 5, isn't it? So plus 3 minus 3 is 0, plus 5 minus 5 0, so the remainder is 0 in this case, isn't it? So therefore we can say x plus 1 is a factor of 3 plus 3x minus 5x cubed plus minus 5x to the power 4. Okay, I hope you got this. Very easy, isn't it? Okay, let's go for question number 5. We are asked to verify whether x plus 1 is a factor of this expression or not. We divide this expression by x plus 1, and if the remainder comes 0, then we can say x plus 1 is the factor of this expression, isn't it? So 0 of the polynomial x plus 1, 0 of the polynomial x plus 1 is x plus 1 equal to 0, so x is minus 1. So let fx equals to this, x to the power 4 plus x square plus x plus 1. Okay, let fx is this expression. Now remainder will be f minus 1, isn't it? Instead of fx, since fx is this, so instead of x we write minus 1. F minus 1 means instead of x we write minus 1. Okay, x means minus 1 whole to the power 4 plus this x means minus 1 whole squared plus instead of this x we write minus 1 plus this 1. Minus 1 whole to the power 4. Since the power is even number, so this minus changes to plus. Okay, 1 into And 1 to the power 4 means 1 multiplied by 1 multiplied by 1 multiplied by 1 multiplied by 1, isn't it? 1 multiplied 4 times. So 1 ones are 1, 1 1 are 1 1. Are you getting me? Yes. So this power is even number. This sign changes to plus. Plus into plus is plus. So 1 square means 1 ones are 1. 1 multiplied 2 times. So plus into minus is minus. This is 1. Then this is plus 1. Isn't it? Here we have 1, 2, 3 positive numbers. 1 plus 1, 2 plus 1, 3. And 1 negative number, minus 1. 3 minus 1 is 2. This is the remainder which is not equal to 0, isn't it? When this expression was divided by x plus 1, we got the remainder 2, which is not equal to 0. Therefore, you can say, therefore, x plus 1 is not a factor of x to the power 4 plus x square plus x plus 1, isn't it? I hope you got that. Number 6. We are asked to verify whether x plus 1 is a factor of this expression or not, isn't it? So what we do is we divide this expression by x plus 1, and if the remainder comes 0, then we can say x plus 1 is the factor of this expression, okay? So 0 of the polynomial x plus 1 is x plus 1 equals to 0 or x equals to minus 1. Plus 1 when we take to the right hand side becomes minus 1, isn't it? Now let fx equals to this expression, okay? Let fx equal to x cube plus x square plus x plus 1, isn't it? Now the remainder will be f minus 1, isn't it? According to remainder theorem, remainder will be f minus 1. We have the value of x is minus 1. So instead of x, we write minus 1, okay? X cube means minus 1 whole cube plus x square means minus 1 whole square plus x means minus 1 and plus 1, isn't it? So since the power is odd number, the sign will remain minus. So this 1 cube is 1 into 1 into 1 is 1. So since the power is even number, this sign minus will change to plus. This plus into this plus is plus. So 1 squared is 1. Plus into minus is minus. This 1 comes here and we have plus 1 here. Okay. Minus 1 plus 1 becomes 0 and minus 1 plus 1 becomes 0. So the remainder is 0 in this case. This means x plus 1 is the factor of this expression, isn't it? X plus 1 is, so we erase this not. So x plus 1 is a factor of x cube plus x square plus x plus 1. I hope you got this. Now let's go for question number 2. Okay. By using factor theorem, let us write whether gx is a factor of the following polynomials fx. We have already completed factor theorem and the remainder theorem as well. Please find the playlist and check out all the exercises from exercise 7.1 to exercise 7.4. Okay, you can find everything in the playlist. Now let's go for question number 2. We are asked to verify whether this expression is a factor of this expression or not. Whether gx is a factor of this polynomial fx. By using factor theorem, let us write whether gx is a factor of the following polynomials fx. Means whether this expression is the factor of this expression or not. Okay, because fx is this and gx is this, isn't it? Whether gx is a factor of fx or not. Okay, now 0 of the polynomial gx, 0 of the polynomial gx means gx is this, isn't it? So x plus 2 equals to 0 or x equals to minus 2, isn't it? This means remainder will be f minus 2, isn't it? F minus 2, x is minus 2, f minus 2. Since fx is this, so f minus 2 will be, instead of x we write minus 2, and if the remainder comes 0, that means this expression is the factor of this expression. If the remainder does not come 0, then this expression is not the factor of this expression. Okay, now let us check. X to the power 4 means instead of x we write minus 2 to the power 4 minus x square means minus 2 square minus 12. Okay, so Since the power is even, 4 is even, so minus will remain plus. Minus will not remain plus, minus will convert into plus, isn't it? Minus will become plus. Since the power is even number, this minus will convert into plus. So 2 to the power 4 means 16, isn't it? 2 into 2 into 2 into 2. 1, 2, 3, 4 times. 2 to the 4, 4 to the 8, 8 to the 16. Are you getting me? Yes. Since the power is even here, 2 is the even number, so this minus will change to plus. So this plus into this minus is minus. Now 2 squared is 4 and we have minus 12, isn't it? So this 16 is positive. Now these two are negative. Minus 4 and minus 12 is minus 16, isn't it? Same sign means number gets added but the sign will remain negative. Okay, now 16 minus 16 is 0. Here we got the remainder to be 0. So we can say x plus 2 is the factor of this expression, which means therefore gx is the factor of fx. Factor of fx. Okay? Are you getting me? Gx means x plus 2, fx means this. So gx is the factor of fx. Yes, you got this. Fx is this and gx is this. We are asked to verify whether gx is the factor of fx or not. So we divide fx by gx, and if the remainder comes 0, then we can say gx is the factor of fx, isn't it? So let, or not let, 0 of the polynomial, 0 of the polynomial gx, 0 of the polynomial gx, which means gx is x plus 5, isn't it? X plus 5 equals to 0, which means x equals to plus 5. When we take to the right hand side, becomes minus 5, isn't it? So now remainder will be f minus 5, isn't it? Remainder will be f minus 5. Since fx is this, so f minus 5 will be, instead of x we write minus 5. Okay, this will give us remainder. 2 x means minus 5 whole cubed plus 9 x means minus 5 whole squared, isn't it? Minus 11 x means minus 5 minus 30, isn't it? So here we have since the power is odd number, 3 is an odd number, so this minus will remain minus. Okay, this minus will remain minus. This minus into this plus, there is no sign means plus, isn't it? Minus into plus is minus. 5 cube is 125. 5 into 5 into 5. 5 multiplied 3 times gives us 125. And 125 into 2 is 250. Okay, 5 5s are 2 5s are 10, 2 to the 4 5, 2 1 the 2, 250. Okay, now since the power is even number, so this sign will change to plus. So this plus into plus is plus. 5 squared is 25. 25 into 9 is 9 5s are 45, isn't it? 9 2s are 18. 18, 19, 20, 21, 22. Are you getting me? Yes. This is very, very simple, isn't it? Minus into minus is plus. So 11 5s are 55. And this is minus 30. All we need to do is add up the negative numbers and add up the positive numbers. Okay? 0 plus 0 is 0. 3 plus 5 is 8. And 5 plus 2 is 7, isn't it? No. 0 plus 0 is 0, 3 plus 5 is 8, and we have 2. We don't have any number here. So 280 minus 280. We have to add these two numbers here. Plus and plus. Plus 5 plus 5 is 10. 5 plus 2 is 7. Plus 1 8. And this 2 becomes 2. So minus 280 plus 280 becomes 0. So here we got the remainder 0. This means gx is the factor of fx. Therefore, you can write gx is the factor of fx. Okay. Fx is this expression and gx is this expression. So we are asked to verify whether x minus 3 is factor of this expression or not. To check this, what we do is we divide this expression by this expression, and if we get the remainder to be 0, then we can say x minus 3 is a factor of this expression. Okay. Now 0 of the polynomial, 0 of the polynomial gx is x minus 3 equals to 0, isn't it? So x equals to minus 3 becomes plus 3. Now remainder will be, if we get the remainder 0, then we can say gx is the factor of fx. So the remainder will be f minus f3, isn't it? Remainder will be f3 will be the remainder. So since fx is this, so f3 will be, instead of x we write 3. Okay, 2x cube means 2, 3 cube plus 7x square means 7, 3 square. Instead of x we are writing 3, okay, because we are writing f3, isn't it? Minus 24 into 3 minus 45. Okay, 3 cube means 3 is a 9, 9 3 is a 27, and 27 2 is a 54, isn't it? Plus 3 square means 9, and 9 7 is a 63, minus into plus is minus 3 24 is a 3 4 is a 12, 3 2 is a 6, 7 3 4 is a 12, 3 2 is a 6, and 7 minus 45. Let's add up the numbers with same sign. These two are similar. These two numbers have similar signs. So 3 plus 4 is 7, and 6 plus 5 is 11, plus 1 1 7, and these two are negative. So let's add up that. 5 plus 2 is 7, and 7 plus 4 is 11. So 117 minus 117 is 0. We got the remainder 0. When fx was divided by gx, the remainder becomes 0. Therefore, we can say gx is a factor of fx. Okay. So fx is this expression and gx is this expression, and we are asked to verify whether gx or this expression is a factor of this expression or not. What we do is we divide this expression by this expression, and if we get the remainder equals to 0, then we can say gx is the factor of fx, isn't it? So by applying remainder theorem or the factor theorem, isn't it? So 0 of the polynomial, 0 of the polynomial gx, 0 of the polynomial gx means gx should be equal to 0, or gx means this, isn't it? So 3x minus 2 should be equal to 0, which means x equals to, you take minus 2 to the right hand side, becomes plus 2, and 3 comes to the denominator, isn't it? 2 upon 3. This 3x, 3 into x, this 3 comes to the denominator. Okay, I hope you got this. Now remainder will be f2 upon 3, isn't it? X is 2 upon 3, so remainder will be f2 upon 3. So instead of x we write 2 upon 3. Okay, since fx is this, so f2 upon 3 will be 3, x means 2 upon 3 whole cubed, plus this x means 2 upon 3 whole squared, minus 20, x means 2 upon 3 plus 12. Just put the value of x as 2 upon 3, okay. Now this 3 we write as it is. So 2 cubed means 2 into 2 into 2, that is 8, isn't it? So 3 cubed means 3 into 3 into 3, that is 27. Okay, plus 2 squared means 4, 2 to the 4, 3 squared means 9, minus 22 is a 40 upon 3 plus 12. 3 1s are 3, 3 9s are 27, isn't it? Now we cannot cancel the numbers. So let's take the LCM. 9, 9 and 3. The LCM will be 9 in the denominator, isn't it? The LCM will be 9 in the denominator. So 9 ones are 9, that 1 into 8 is 8, plus 9 ones are 9, that 1 into 4 is 4, minus 3 threes are 9, and that 3 into 40 is 3 fours are 12, 0, the 0 comes here, plus we have 1 in the denominator of 12, so 1 into 9 is 9, and that 9 into 12 is 108, isn't it? 9 12 are 108. Now let us add up the positive numbers and subtract the negative. Okay, 8 plus 4 is 12, 12 plus 108 is 100. Let me add here, 108 plus 8 plus 4, 12, isn't it? 8 9 10, 1 2 1. 8 plus 2 is 10, 1 plus 0 is 1, and that 1 is 2. This one comes down here. So we have 120 positive minus 120 negative divided by 9, isn't it? So 120 minus 120 is 0, 0 upon 9. 0 upon 9 means 0. If the number in the numerator is 0, whatever be the number in the denominator, the answer will be 0. Okay, so we have the remainder to be 0. That means gx is the factor of fx. Okay, let me write here. Therefore gx is a factor of fx. Are you getting me? Yes. Number 3, let us calculate and write the value of k for which the polynomial 2x to the power 4 plus 3x cubed plus 2kx square plus 3x plus 6 is divided by x plus 2. Okay, x plus 2 is a factor of this expression. It's already given to us. X plus 2 is a factor of this expression, and the question is asking, when this expression is divided by x plus 2, then what will be the value of k? Okay, we are asked to find the value of k. How to solve this? Solution: 0 of the polynomial x plus 2 x plus 2 equals to 0, or x equals to plus 2, and we take to the right hand side, becomes minus 2, isn't it? Okay, now since x plus 2 is a factor of 2x to the power 4 plus 3x cubed plus 2k x square plus 3x plus 6. Okay, that means remainder f minus 2, isn't it? Remainder f minus 2 should be equal to 0. If the remainder equals to 0, then only x plus 2 will be the factor of this expression, isn't it? If the remainder is not equal to 0, that means if the remainder is not 0, that means x plus 2 will not be the factor of this expression. To be the factor of this expression, the remainder should be equals to 0. To become x plus 2 a factor of this expression, the remainder should be equals to 0. Okay, this is the condition. Remainder equals to 0, f minus 2 equals to 0. Okay, since let fx equals to, let fx equals to 2x to the power 4 plus 3x cubed plus 2k x square plus 3x plus 6, isn't it? So fx equals to, this means f minus 2 will be equals to, instead of x we write minus 2, isn't it? 2x means minus 2 whole to the power 4 plus 3x means minus 2 whole cubed plus 2k x means minus 2 whole square plus 3, x means minus 2 plus 6. Okay, now since f minus 2 is 0, so instead of f minus 2 we write 0 equals to, since the power is even number, this sign changes to plus. Minus into plus is minus. Sorry, this minus changes to plus. Plus into plus is plus. Okay, no need to write plus in front. F minus 2, the value of f minus 2 is 0. So instead of f minus 2, we are writing 0 here. Since the power is even number, the sign will change to plus. This minus will change to plus. Okay, this minus becomes plus, and this plus into plus is plus. So no need to write plus in the front. So 2 to the power 4 means 16, isn't it? 2 into 2 into 2 into 2. 16 2s are 32. 16 2s are 32. 16 2s are 32. Since the power is odd number, this sign will remain minus, isn't it? So minus into plus is minus. 2 cube means 8. 8 3s are 24. Now the power is even number. Here the power is even number. This sign will change to plus. This plus into this plus will become plus. Okay. Now 2 squared is 4. 4 2s are 8. 8k, isn't it? Now we have plus into minus is minus. 3 2s are 6. And we have plus 6. Okay. Minus 6 and plus 6 becomes 0. We can cancel here. Now, or 32 minus 24 is 8, isn't it? 32 minus 24. Plus 32 minus 24 is 8. Plus 8 when we bring to the left hand side becomes minus 8. Minus 8 equal to 8k. Okay. Are you getting me? Plus 32 minus 24 is plus 8 because the sign of greater number comes here. And that plus 8 when we bring to the left hand side becomes minus 8. And we have 8k in the right hand side. Or minus 8 upon this 8 comes in the denominator is equal to k. Now you can cancel this and write therefore k equals to minus 1, isn't it? K equals to minus 1. We were asked to find the value of k and the value of k is minus 1. Okay, number 4. Let us calculate the value of k for which gx will be a factor of the following polynomials fx. Okay, gx is the factor of the polynomial fx. This is a given condition. Gx is the factor of the polynomial fx, and we are asked to find the value of k. Okay, we are asked to find the value of this k. What we do is we find 0 polynomial, 0 of the polynomial gx. 0 of the polynomial gx means x minus 1. Gx is x minus 1, isn't it? X minus 1 should be equals to 0, or x equals to minus 1 when we take to the right hand side becomes plus 1, isn't it? So x minus 1 equals to 0 means x equal to 1. So remainder will be f1, isn't it? Remainder will be f1, x is 1. But given condition is that gx is the factor of fx, isn't it? Gx is a factor of fx. That means therefore remainder should be equals to 0. Remainder should be equals to 0, or which means f1 should be equals to 0. F1 should be equals to 0 since gx is a factor of fx. Okay. Now f1 equals to, instead of fx I am finding f1. Okay, fx equals to this expression means f1 equals to, instead of x I write 1, isn't it? 2x means 1 whole cubed plus 9x means 1 whole squared plus x means 1 plus k. Okay, now f1 is 0 because f1 is the remainder, so remainder should be 0. Remainder should be 0 to become gx, a factor of this expression. So remainder is 0. Instead of f1 I write 0. So 1 cubed is 1, 1 into 2 is 2 plus 1 squared is 1, that 1 into 9 is 9, plus 1 plus k, isn't it? So 0 equals to 2 plus 9, 11, 9, 10, 11, plus 1 is 12, 12 plus k, isn't it? Therefore k equals to plus 12, when we take to the left hand side becomes minus 12, isn't it? So we were asked to find the value of k, and the value of k is minus 12, isn't it? Question number 2, fx is this and gx is this. We are asked to find the value of k, and given condition is gx is a factor of this polynomial fx, okay, which means the remainder should be equals to 0, okay. Now let us write 0 of the polynomial, 0 of the polynomial gx. 0 of the polynomial gx means gx should be equals to 0, okay. That means gx is x minus 1, that means x minus 1 should be equals to 0, or x equals to minus 1, we take to the right hand side becomes plus 1, isn't it? Now remainder equals to, since gx is a factor of fx, so remainder f1 should be equals to 0, isn't it? Remainder f1, remainder will be f1, isn't it? Remainder f1 should be equals to 0. Now since we have fx equals to kx square, fx equals to kx square minus 3x plus k, isn't it? Fx equal to kx square minus 3x plus k. Now remainder will be f1, so f1 equals to, instead of x we write 1, isn't it? 1 square minus 3x means 1 plus k, and f1 is 0. Instead of f1 I write 0. 0 equals to 1 squared is 1, 1 into k is k, minus 3 ones are 3 plus k, or minus 3 when we bring to the left hand side becomes plus 3, 3 plus 0 is 3, equals to k plus k is 2k, isn't it? Or k equal to 3 we have in the left hand side, this 2 comes in the denominator, 3 upon 2. Now this is an improper fraction because the number in the denominator is smaller than the numerator, so we convert this into mixed fraction. 2 ones are 2, 3 minus 2 is 1, so we write 1 whole 1 upon 2. The value of k is 1 whole 1 upon 2. Fx is this expression and gx is this expression, and gx is a factor of fx, isn't it? So that means the remainder should come 0. The remainder should be 0, okay? Now let's begin. 0 of the polynomial gx. 0 of the polynomial gx means the value of gx should be equals to 0. That means gx is this, isn't it? 2x minus 3. So 2x minus 3 equals to 0, or x equals to minus 3, when you take to the right hand side becomes plus 3, and this 2 comes in the denominator, isn't it? X equals to 3 upon 2. Now since gx is a factor of fx, isn't it? Gx is a factor of fx, therefore f 3 upon 2, that is remainder, isn't it? Remainder should be equals to 0, okay? Now f 3 upon 2 equals to, fx is this, so f 3 upon 2 means instead of x we write 3 upon 2, okay? Instead of x we write 3 upon 2. 2 into x means 3 upon 2. 3 upon 2 whole to the power 4, plus this x means 3 upon 2 whole cubed, minus k, x means 3 upon 2 whole squared minus x means 3 upon 2 plus 6. Okay, f3 upon 2 is 0. Remainder should be 0 because gx is the factor of this expression. To become a factor, remainder should come 0, isn't it? This means this f3 upon 2 is 0, or equals to 2 into 3 to the power 4 means 3 into 3, 9, 9 3 is 27, 27 3 is 81. 81 upon 2 to the power 4 means 16, isn't it? Plus 3 cubed means 3 3 is 9, 9 3 is 27. 2 cubed means 8, 2 2 is 4, 4 2 is 8, minus k into 3 square means 3 3 is 9, 2 square means 2 2 is 4, minus 3 upon 2, 3 upon 2 plus 6, isn't it? Now 2 1s are 2, 2 8s are 16, equals to 81 upon 8, 81 upon 8 plus 27 upon 8 minus 9 into k is 9k, isn't it? 9k upon 4 minus 3 upon 2 plus 6 upon 1. Okay, if there is no number in the denominator, we can consider there is 1, isn't it? So now let us 16 to addition. Let us take the LCM of the denominator. Please let me erase this. Please take the screenshot. Okay, I'm erasing this part so that I can continue the sum. The LCM of 8, 8, 4, 2 and 1 is 8, isn't it? We have 0 in the left hand side, 0 equals to, yes, 0 is here, or 0 equals to 8 1s are this 8, isn't it? That 1 into 81 is 81 plus 8 1s are 8, 8 1s are 8, isn't it? That 1 into 27 is 27 minus 4 2s are 8, that 2 into 9 is 18k minus 2 4s are is 8, that 4 into 3 is 12 plus 1 8s are 8, that 8 into 6 is 48, isn't it? Are you getting me? Yes. I hope you know how to take the LCM. 0 equal to 8 into 0, we cross multiply this, okay? 8 into 0 is 0. Now let us add all the positive numbers and subtract the negative one. 81 is positive, 27 is positive, and 48 is positive, 12 is negative, isn't it? So 8 plus 7, 15, plus 1, 16. 16 means 6. 4 plus 1, 5. 5 plus, sorry, this is negative, isn't it? 4 plus 2, 6. 6 plus 8, 14, plus 1, 15. And we have this minus 12 and minus 18k, isn't it? So 8 into 0 is 0, or 0 equal to 6 minus 2 is 4, 5 minus 1 is 4, and 1 comes here, minus 18k. Now let me erase this also, or bring this 144 minus 18k to the left hand side. Minus 18k becomes plus 18k equals to 144, isn't it? If we do here, k equals to 144 upon 18. 3 6 is 18, 3 4 is 12, 13 14, 3 8 is 24, 6 1 is 6, 6 8 is 48, or k equals to 8. We were asked fx is this expression and gx is this expression, and given to us gx is a factor of this expression. That means remainder should be equal to 0. Okay, remainder should be 0, and we are asked to find the value of k. 0 of the polynomial gx. 0 of the polynomial means gx should be equals to 0, isn't it? So gx is this and this should be equals to 0. 2x minus 1 equals to 0, which means or x equals to minus 1 when we take to the right hand side becomes plus 1, and this 2 comes to the denominator, isn't it? 1 upon 2, x equals to 1 upon 2. Since gx is a factor, this is given to us, factor, isn't it? Gx is a factor of fx, therefore remainder, no need to write remainder, we can understand this is remainder. f1 by 2 will be a remainder, isn't it? f1 by 2 is the remainder, f1 by 2 should be equal to 0. Since gx is the factor of fx, so remainder f1 by 2 should be equal to 0, okay? Now, or f1 by 2 equals to, since fx is this, isn't it? So instead of x we write 1 by 2. f1 by 2 will be equals to 2, x means 1 by 2 whole cubed plus k, x means 1 by 2 whole square plus 11, x means 1 by 2 plus k plus 3, isn't it? Or f1 by 2 is 0 equals to 2 into 1 cubed is 1, 2 cubed is 8 plus 1 squared is 1, that 1 into k is k, divided by 2 squared is 4, plus 11 ones are 11 upon 2 plus k plus 3 upon 1, okay? 1, 2 ones are 2, 2 fours are 8, or 0 equal to, now we have 4, 4, 2, 1, 1. The LCM will be 4, isn't it? LCM will be 4. So 4 ones are 4. That 1 into this 1 is 1. Plus 4 ones are 4. This 1 into this k is k. Plus 2 twos are 4. That 2 into 11 is 22. Plus 1 fours are 4. That 4 into k is 4k. Plus 1 fours are 4. That 4 into 3 is 12. I hope you are getting me. Let me do this here. Now we have 4 into 0. We can cross multiply this. 4 into 0 is 0, or 0 equal to, in the right hand side, k plus 4k is 5k. K plus 4k is 5k, and we have 1, 22 and 12. All three numbers are positive, so let's add up. 1 plus 2 is 3, 3 plus 2 is 5. 5, isn't it? 5, 1 plus 2 is 3, 35 plus 22 plus 1, 23, 23 plus 2, 23 plus 12, 5 to 3, 35, yes, 35 over 400. Now let's bring this 5k to the left hand side. Minus 5k, isn't it, equals to 35, or k equals to 35 upon this 5 minus 5 comes in the denominator. 5 on the 5, 5 7 the 35, or k equal to, minus is in the denominator, bring this minus to the numerator, and that k equal to minus 7. A and B, if x square minus 4 is a factor of the polynomial this, okay? X square minus 4 is the factor of the polynomial this, and we are asked to find the value of A and B, okay? Now 0 of the polynomial, 0 of the polynomial x square minus 4, x square minus 4 equal to 0, isn't it? Or you can write x square minus 4 means 2 square equal to 0, or 4 means 2 square, isn't it? Or you can write x plus 2 into x minus 2 equals to 0. A square minus b square equal to a plus b into a minus b equal to 0. Either x plus 2 equals to 0 or x minus 2 equals to 0. The product of these two numbers equals to 0 means either this should be equals to 0 or this should be equal to 0. One of these two numbers should be equal to 0 or both should be equal to 0. Okay, that means x plus 2 equal to 0 means or x equals to, we get minus 2. If this is 0, then we get x equals to minus 2 becomes plus 2, isn't it? We have two values of x, that is minus 2 and plus 2. Since the power of x is 2, we get two values of x. Okay, now since x square minus 4 is a factor of ax, let this be fx. Okay, let this be fx. I don't write all along these things. Fx means this. Okay, ax to the power 4 plus 2x minus 3x square plus bx minus 4 is fx. I'm just supposing it because it takes a lot of time to write all these things, isn't it? X square minus 4 is a factor of fx. Okay, that means remainder will be f minus 2 and f plus 2, isn't it? First case when the remainder is f minus 2. F minus 2. F minus 2 should be equal to 0 because this is a factor of the expression, this expression, isn't it? So fx equals to, we have ax to the power 4, ax to the power 4 plus 2x cube minus 3x square plus bx minus 4, isn't it? So f minus 2 will be the one remainder, f minus 2. Ax to the power 4 means x means minus 2 whole to the power 4 plus 2x means minus 2 whole cubed minus 3 means x means minus 2 whole square plus b x means minus 2 minus 4, isn't it? Since f minus 2 is the remainder and remainder should be equal to 0 because this is the factor of the expression this, so f minus 2 is 0 or 0 equals to, since the power is even number, so this minus will become plus, so plus into plus is plus. 2 to the power 4 is 16, 16 into a is 16a. Since the power is odd number, so this minus will remain minus, and this minus into plus is minus. 2 cube is 8, 8 2 is 16. Since the power is even number, so this minus will change to plus, and this plus into minus is minus. 2 square is 4, 4 3 is 12. Plus into minus is minus, b into 2 is 2b minus 4. Okay, or 0 equal to 16a minus 2b minus 2b minus 2b, okay, minus 16 minus 12 minus 4, all are negative, so let's add up. 6 plus 2 8, 8 plus 4 12, isn't it? 1 2 and 1 3, 32 minus 32. Okay, now let's bring this minus 32 this side. 16a minus 2b equals to 32. Minus 32, when we bring this to the left hand side, becomes plus 32. Okay, now you can divide this equation throughout by 2 to reduce the number. We get, let me write here, okay, 2 on the 2, 2 8 is 16, 8a, 2 cancels, 2 16 is 32, isn't it? We get 8a minus b equal to 16, isn't it? This is equation 1. Now please take the screenshot of this. I am going to erase. Okay. Now we have another value of x, that is 2, isn't it? So in this case also, second case, remainder will be f2, isn't it? Remainder will be f2 and f2 will be equals to 0. Since fx equals to ax to the power 4, ax to the power 4 plus 2x cube minus 3x square plus bx minus 4. I am taking this 2. I already did this minus 2. Now I am taking this 2. Okay, f2 will be equals to, instead of x I write 2. Okay, a 2 to the power 4 plus 2, x means 2 cubed minus 3, x means 2 whole square plus b into this x means 2 minus 4, isn't it? Or f2 means 0, remainder should be equal to 0, isn't it? Or a equals to 2 to the power 4 means 16, 16 into a is 16a plus 2 cubed is 8, 8 2 is 16, 2 to the 4, 4 3 is 12 minus 12 plus 2 into b is 2b minus 4. Or 0 equal to 16a plus 2b, 16 minus 12 minus 4, that is minus 16, and plus 16 becomes 0, isn't it? Minus 12 minus 4, minus 16 and plus 16 becomes 0. So let's divide this equation throughout by 2, 2 and 2. 2 cancels, 2 and the 2 is 16, 2 0 is 0. Okay. Now equation 2 is 8a plus b. 8a plus b equals to, we have 0 in the right hand side. This is equation 2. Okay. Now please take the screenshot. I am going to solve equation 1 and 2. Equation 1 we have 8a minus b equals to 16, isn't it? Solving 1 and 2. Solving equation 1 and 2. In equation 1 we have 8a minus b equal to 16 equal to equation 1. In equation 2, 8a plus b equal to 0. This is equation 2. So let's add up these two equations. Adding minus b and plus b cancels out. 8a plus 8a is 16a equal to 16 plus 0 is 16. A equals to this 16 divided by this 16 comes in the denominator. So a equals to 1, isn't it? Putting the value of a, putting the value of a in equation 1. Okay, equation 1, 8a minus b is 16, isn't it? 8a minus b equals to 16. 8 into a means 1. A means 1 minus b equal to 16. Or 8 1s are 8, minus b equals to 16 plus 8. If you take to the right hand side, becomes minus 8. Minus b equals to 16 minus 8 is 8, isn't it? So this minus you take to the right hand side, b equals to minus 8. Okay, a equals to 1 and b. Therefore, we were asked to find the value of a and b. A equals to 1 and b equals to minus 8. We have minus b equals to 8. 16 minus 8 is 8. Now we take this minus sign to the right hand side, minus 8. Or multiplying both sides by minus sign. Minus into minus is plus and minus into plus is minus. Okay, I hope you understood this. If x plus 1 and x plus 2 are the two factors of this expression, then let us calculate and write the values of a and b. Okay, x plus 1 is also a factor of this expression and x plus 2 is also a factor of this expression. Then what are the values of a and b? We are asked to calculate the values of a and b. Okay, let us first start with this. Since 0 of the polynomial of the polynomial x plus 1 equal to 0, isn't it? Or x equals to minus 1. Plus 1 becomes minus 1 when we take to the right hand side. Since x plus 1 is a factor of x cubed plus 3x squared plus 2ax plus b, isn't it? X plus 1 is a factor of this. This means remainder will be f minus 1. Remainder will be f minus 1. F minus 1 will be equals to 0, isn't it? Therefore, remainder will be equal to 0. Because to become a factor, since x plus 1 is a factor of this, to become a factor of this expression, f minus 1 or the remainder should be equals to 0. If the remainder is not equal to 0, then x plus 1 will not be the factor of this expression, isn't it? So let fx equal to x cube plus 3x square plus 2ax plus b, okay? Or remainder f minus 1 will be equal to, instead of x we write minus 1, isn't it? Minus 1 whole cube plus 3, x means minus 1 whole square plus 2, a, x means minus 1 plus b, x means minus 1. Or f minus 1 is 0, equal to minus 1 whole cube means, since the power is odd number, sign will remain minus, 1 cubed means 1, power is even, so sign will change to plus, so 1 plus into plus is plus, 1 into 3 is 3, plus into minus is minus, 2a into 1 is 2a plus b, okay? Now let us bring this 2a and b to the left hand side. Minus 2a becomes plus 2a, plus b becomes minus b, equal to, in the right hand side we have plus 3 and minus 1. 3 minus 1 is 2, isn't it? This is equation 1. Okay, now please take the screenshot of this. I am going to erase the upper part of the board to make some space for the equation 2. Let me write the equation 1 here. 2a minus b equal to 2. This is equation 1, okay? Please take the screenshot of this. I am going to erase this. 2a minus b equal to 2. Now we have another expression. X plus 2 is also a factor of this expression, isn't it? 0 of the polynomial of the polynomial x plus 2. X plus 2 equals to 0, which means x equals to minus 2, isn't it? Since x plus 2 is a factor of x cubed plus 3x square plus 2ax plus b, isn't it? So f minus 2, that is remainder, should be equals to 0, isn't it? Let fx equals to x cubed plus 3x square plus 2ax plus b. Fx equals to this, okay? Now remainder f minus 2 will be equals to, instead of x I write minus 2, okay? Instead of x I write minus 2. Minus 2 whole cubed plus 3, x means minus 2 whole squared plus 2, a, x means minus 2 plus b, isn't it? Or f minus 2 is 0, or minus 2 cubed means odd number, so sign will remain minus. 2 cubed means 8. Square is even number, so this minus changes to plus. Plus into plus is plus. 2 squared is 4, 4 3s are 12. Plus into minus is minus. 2 into 2 is 4a. isn't it? Plus b. Now let us bring this minus 4a to the left hand side, becomes plus 4a, plus b becomes minus b, equals to, we have plus 12 and minus 8, 12 minus 8 is 4, isn't it? So this is equation 2. We already have equation 1 and this is equation 2. Now let us solve equation 1 and 2 to find the value of a and b. Okay, please take the screenshot quickly. I am going to erase this. Okay. Solving 1 and 2. 1 and 2. In equation 1 we have 2a minus b equal to 2. This is equation 1. Equation 2, 4a minus b equal to 4. This is equation 2, isn't it? Subtracting, this minus 4a becomes plus 4a becomes minus 4a, minus b becomes plus b, plus 4 becomes minus 4, isn't it? So 4a is negative, 2a is positive, so 4a minus 2a is 2a. Sign of greater number comes, that is minus. Minus b and plus b cancels out, equals to minus 4 is negative and this 2 is positive. 4 minus 2 is 2. Sign of greater number comes here. Minus and minus cancels out. A equals to 2 upon this 2 comes in the denominator. So 2 and the 2. Therefore a equals to 1. If we know the value of a, we can find the value of b also, putting the value of a in equation 1. Okay, putting the value of a in equation 1. Equation 1 we have 2a minus b equal to 2, or 2a means 1, isn't it? A means 1 minus b equal to 2, or 2 1s are 2 minus b equal to 2, or minus b equal to 2. Plus 2 take to the left hand side, right hand side becomes minus 2. Minus b equals to 2 minus 2 is 0. Therefore b equals to 0. Therefore a equals to 1 and b equals to 0. Okay, let's move on to the next question. Question number 7. If the polynomial ax cubed plus bx squared plus x minus 6 is divided by x minus 2 and remainder is 4, then let us calculate the values of a and b when x plus 2 is a factor of this polynomial. Okay, when this expression was divided by x minus 2, the remainder is 4, the first case, and the second case is x plus 2 is a factor of this expression. There are two cases. Okay, in the first case we are given that when this expression is divided by x minus 2, remainder will be 4, and the second case is this expression, x plus 2 is a factor of this expression, means the remainder is 0 in that case. Okay, now we are asked to find the values of a and b. Let us start from the first case. Let fx equal to ax cubed plus bx squared plus x minus 6, okay, is divided by x minus 2 and remainder is 0. Remainder is 4. Remainder is 4, isn't it? 0 of the polynomial x minus 2 is x minus 2 equals to 0, isn't it? Or x equals to minus 2 becomes plus 2, minus 2 becomes plus 2, isn't it? So remainder will be f2. Remainder will be f2. When this expression is divided by x minus 2, remainder will be f2, isn't it? Remainder will be f2. Remainder equals to, since fx is this, isn't it? So f2 will be, instead of x we write 2. So a, x means 2 cubed, plus b, x means 2 squared, plus x means 2 minus 6. We have f2 is 4, remainder is 4, isn't it? Remainder is 4. Instead of f2 we write 4 equals to 2 cubed means 8. 8 into a is 8a plus 2 squared means 4. 4 into b is 4b minus 6 minus 2 is 4. Isn't it? 6 minus 2 is 4 and the sign of greater number comes minus. So minus 4. Let's bring this minus 4 to the left hand side. 4 plus 4 minus 4 becomes plus 4 equals to 8a plus 4b, isn't it? Or let's bring all together 8a plus 4b to the left hand side. 8a plus 4b equals to 4 plus 4 is 8. Let's divide throughout the equation by 4 to reduce the number, or 4 1 is 4, 4 2 is 8, 4 and 4 cancels out, 4 2 is 8, isn't it? Therefore we have 2 into a, 2a plus we have b equal to, we have 2 in the right hand side. This is equation 1, okay? Let me copy this equation here. A plus b equal to 2. This is equation 1. Please take the screenshot. Now I am going to start the second case. Second case is x plus 2 is a factor of x plus 2 is a factor of this expression, isn't it? And x plus 2 is a factor of fx, isn't it? So fx means this. 0 of the polynomial of the polynomial x plus 2, that means x plus 2 equals to 0, or x equals to plus 2 becomes minus 2 when we take to the right hand side, isn't it? Now remainder will be f minus 2. Remainder will be f minus 2, isn't it? Since fx is this, means f minus 2 will be, instead of x we write minus 2, a into minus 2 whole cube plus b into x means minus 2 whole square plus x means minus 2 minus 6, isn't it? So since the factor x plus 2 is a factor of this expression fx, this means f minus 2 will be equal to 0, isn't it? Since x plus 2 is a factor of this expression, means remainder should be equal to 0. F minus 2 is a remainder, so remainder should be equal to 0, okay? Here, since the power is odd number, so the sign will remain minus. Minus into plus is minus. 2 cube is 8, 8 into a is 8a. Power is even number, so the sign changes to plus. Plus into plus is plus. 2 2 is 4, 4 into b is 4b. Plus into minus is minus 2 minus 6. Okay. Let's bring this minus 8a to the left hand side. Minus 8a becomes plus 8a, isn't it? 8a plus 4b becomes minus 4b equals to, in the right hand side, these two are brought to the left hand side. In the right hand side we have minus 6 and minus 2, that is minus 8. Now let's reduce this by dividing throughout by 4. 4 1 is 4, 4 2 is 8, 4 and 4 cancels out, 4 1 is 4, 4 2 is 8. Or 2 into a is 2a minus b equal to minus 2, isn't it? Minus 2. This is equation 2. Now let us solve this equation 2 and this equation 1. Okay? Please take the screenshot. I am erasing this. Now solving equation 1 and 2, we will find the value of a and b. Okay? Solving equation 1 and 2. Equation 1 we have 2a plus b equal to 2, isn't it? 2a plus b equal to 2. Equation 2 we have 2a minus b. 2a minus b equal to minus 2. This is equation 2. So adding 2a plus 2a, that is 4a, plus b and minus b cancels out, plus 2 and minus 2 cancels out, or a equals to 0 upon 4, or a equals to 0. Putting the value of a in equation 1, putting the value of a in equation 1. In equation 1 we have 2a plus b equal to 2, 2a plus b equal to 2, or a is 0, so 2 into 0 plus b equal to 2, or 2 into 0 is 0, 0 plus b is b equal to 2. Therefore a equal to 0 and b equal to 2. The value of a and b are a equal to 0 and b equal to 2. I hope you got this. Now let's move on. Let us show that if n is any positive integer, even or odd, x minus y is a factor of the polynomial x to the power n minus y to the power n. Okay, n is positive integer, means n equal to 1, 2, 3 and so on. Okay, then we are asked to prove that x minus y is factor of this. Okay, factor means we are asked to prove that when x to the power n minus y to the power n is divided by x minus y, then the remainder should be equal to 0. Okay, if we can prove when this expression is divided by x minus y, if the remainder comes 0, then we can say x minus y is a factor of this expression, isn't it? Let x to the power n minus y to the power n is divided by x minus y, and the quotient is q, and remainder without x. Okay, remainder should be without x, means remainder should be constant number free of variable. Okay, and remainder without x is r. Okay, we are considering the remainder as a constant number without a variable number x, so we consider the remainder to be r. Since we know that dividend equals to divisor into quotient plus remainder, isn't it? Or dividend is what? X to the power n minus y to the power n. This expression is being divided by this expression, isn't it? This expression is being divided by this expression, so dividend is this and divisor is x minus y, and quotient is q, and remainder is r, isn't it? So since r remainder r does not contain x, isn't it? Contain x. So for any value of x, the value of r does not change, isn't it? Remainder r does not contain x. This r is free from x. This is a constant number. So since this remainder does not contain x, means for any value of x, the value of r does not change, isn't it? Because this r does not contain x, so for any value of x in this identity, the value of r does not change. This is an identity. Okay, this is an identity. This is an identity. Okay, now let x equals to y. Okay, we are supposing the value of x to be y. Then in that case, what happens if we put the value of x equals to y in this equation? we have y, instead of x we write y to the power n minus y to the power n equals to, x means y minus y into q plus r, isn't it? Or let me do this here, y to the power n minus y to the power n, same number minus same number. These two numbers are same, the signs are opposite, means the value will be 0, isn't it? 0 equals to y minus y is 0, 0 into q is 0, 0 plus r, isn't it? Therefore r equal to 0, means we got the remainder to be 0. Since remainder equal to 0, that means we can say x minus y is a factor of x to the power n minus y to the power n. Therefore x to the power x minus y is a factor of x to the power n minus y to the power n. Okay, I hope you got this. Let us show that if n is any positive odd integer, then x plus y is a factor of x to the power n plus y to the power n. X plus y is a factor of x to the power n plus y to the power n, isn't it? Where n is positive odd integer, okay? N equals to, can be 1, 3, 5, 7 and so on. Odd integer, n should be positive odd integer, okay? Let's prove this. Let x to the power n plus y to the power n is divided by x plus y, and the quotient be q, and remainder without x, okay? Remainder without x be r. Remainder should be free from variable number, okay? Remainder should be a constant number. Okay, since we know that dividend equals to divisor into quotient plus remainder, isn't it? Or dividend is this one, x to the power n minus y to the power n. Divisor is x plus y, isn't it? Into quotient is q plus remainder is r, isn't it? Now this is an identity, okay? This is an identity. Now let x equals to y. Let x equals to y. I am just supposing the value of x to be y, because r is independent of x, isn't it? R is independent of x, independent of x, and the value of r does not change for any value of x, okay? R is independent of x, so when you change the value of x, the value of r does not change. So if you suppose x equals to y, then let's put the value of x, okay? Let's put the value of x as y, okay? Oh, here we have plus x to the power n plus y to the power n, x to the power n plus y to the power n. X equals to minus y. Let's suppose x equals to minus y. Now let's put the value for x to the power n means minus y whole to the power n, isn't it? Minus y whole to the power n plus y to the power n equals to x means minus y plus y into q plus r. Or if this n is odd number, the sign will remain minus, isn't it? And if this n is even number, this sign will change to plus, isn't it? If the power is odd number, the sign will remain minus, and if this is even number, the sign will change to plus. Suppose if this n is even number, then the sign will change to y to the power n plus y to the power this y to the power n. This will not subtract from each other, isn't it? Since n is positive even number, if n is even number, then this minus sign will change to plus. So in this question we are given that n is any positive odd integer. N is odd integer means when the power is odd, this sign will remain minus. Okay, y to the power n plus y to the power n. Okay, equal to minus y plus y, 0. 0 into q is 0. 0 plus r, isn't it? Minus y plus y is 0. 0 into q becomes 0. 0 plus r. Or these two numbers are same and signs are opposite, so this becomes 0. 0 equal to r. Therefore remainder becomes 0, isn't it? Therefore remainder becomes 0. Remainder becomes 0 means x plus y is factor of x to the power n. Therefore x plus y is a factor of x to the power n plus y to the power n. Okay, see here, if the power was even number, then this would have been plus, so these two would have never been cancelled, isn't it? So y to the power n plus y to the power n would have given 2y to the power n. So the remainder would have not been 0 like this, isn't it? So now in this case we have the power as odd number, so we got minus here, and this cancels out and becomes 0. In this case x plus y is a factor of x to the power n plus y to the power n. I hope you got this. Number 10, let us show that if n be any positive integer, even or odd, then x minus y never be a factor of the polynomial x to the power n plus y to the power n. Okay, then which means when this expression x to the power n plus y to the power n is divided by x minus y, then the remainder will never come 0 for any values of n, even or odd. Whether n be an even number or odd number, when this expression is divided by this expression, the remainder will never become 0. Okay, that means x minus y will never be a factor of this polynomial x to the power n plus y to the power n. Let's do this. Let x to the power n plus y to the power n be divided by x minus y, and the quotient be q, and remainder without x be r. Okay, remainder without x means the value of remainder should be free from variable number x. Okay, since we know that dividend equals to divisor into quotient plus remainder, isn't it? Remainder. Or dividend equals to this x to the power n plus y to the power n, isn't it? This is being divided plus y to the power n equal to divisor means x minus y into quotient means q plus remainder means r. This is an identity. This is an identity. Okay. Now, since r does not contain x, so the value of r does not change for any value of x. Okay, since r does not contain, since this r does not contain x, so this value of r does not change for any value of x. Now let us suppose x equals to y. Let x equals to y, because when we suppose x equals to y, y minus y becomes 0, isn't it? This can be 0. Otherwise, if we suppose x equals to minus y, then this becomes minus y and minus y becomes minus 2y, isn't it? X equals to y. I am supposing x equals to y. Okay. Then here comes, if I put this value x equals to y in this equation, y to the power n plus y to the power n equals to x means y minus y into q plus r, isn't it? Or y to the power n plus y to the power n, both are same number and having same sign, so this should be added. 2y to the power n equal to 0 into q is y minus y is 0, isn't it? 0 into q is 0, 0 plus r is r. So remainder is not 0, remainder is 2y to the power n. That means when the remainder is not 0, this factor, this cannot be a factor of this expression. Okay, x minus y cannot be a factor of this expression. If we do not put the value of x to be y, or if we put the value of x as minus y, then this can become 0, but this will not be 0 in this case again. Minus, if we put here minus y, then this will become 0, but this will become minus y, it becomes minus 2y, isn't it? Minus 2y into q is minus 2y cube. When we bring that to right left hand side, it becomes plus 2y cube. So in this case, remainder is not 0. So since remainder is not equal to 0, therefore x minus y is not a factor of x to the power n plus y to the power n. I hope you understood this. Okay, let's start MCQ question number 11. Question number 1 of 11. The polynomial x cube plus 6x square plus 4x plus k is divisible by x plus 2. Then the value of k is, we are provided with the 4 options A, B, C and D. Among these, which option will be the value of k? Okay, let's solve this. Since this expression is divided by x plus 2, isn't it? So 0 of the polynomial x plus 2, that is x plus 2 equals to 0, or x equals to plus 2, when we take to the right hand side becomes minus 2. So remainder will be f minus 2, isn't it? Let fx equal to, let fx equal to x cube plus 6x square plus 4x plus k, or remainder will be f minus 2. F minus 2 equal to x cube means minus 2 cube plus 6x square means 6x means minus 2 square plus 4x means minus 2 plus k, isn't it? And we are provided with the information that this expression is divisible by this, means x plus 2 is factor of this, isn't it? So f minus 2 is remainder, remainder should be equal to 0, isn't it? You can write, since x plus 2 is a factor of fx, isn't it? So therefore f minus 2, that is remainder, should be equal to 0. Okay, f minus 2 should be equal to 0, this should be equal to 0, or minus 2 cube means, since the power is odd number, so sign will remain minus. 2 cube means 8. This is even, so sign changes to plus. When the power is even number, sign changes to plus. This plus into this plus is plus. So 2 square is 4, 4 6 is 24. Plus into minus is minus, 4 2 is 8 plus k. Now let us bring this k to the left hand side, minus k. plus k becomes minus k. Now minus 8 and minus 8 is minus 16, isn't it? Plus 24. Or minus k equals to 24 minus 16 is 4 minus 6, 14 minus 6 is 8, and this becomes 1 minus 1 is 0. So sign of greater number comes a plus. Now multiplying both sides by minus sign, minus into minus becomes plus k, and minus into plus becomes minus 8. So k is minus 8. So we have to choose the option minus 8. That means C is the correct option. Next question. In the polynomial fx, if f minus 1 upon 2 equals to 0, then the factor fx will be, which among these a, b, c, d will be the factor of fx if f minus 1 upon 2 equals to 0. Okay, let's check with this. F minus 1 upon 2, since let fx equals to this, okay, fx equals to 2x minus 1, we have to check each of this. So f minus 1 upon 2 will be equals to, should come 0, isn't it? F minus 1 upon 2 should come 0. F minus 1 upon 2 equals to 2 into x means minus 1 upon 2. Minus 1 upon 2. Minus 1. Okay? X means minus 1 upon 2. I am putting the value of x. Since fx is this, so f minus 1 upon 2 means instead of x, I write minus 1 upon 2. 2 and 2 cancels out, so minus 1 and minus 1 is minus 2, isn't it? So this is not the option. Number A is not the option. Let's check out with the option number B. So fx equals to 2x plus 1. F minus 1 upon 2 equals to 2 minus 1 upon 2 plus 1, isn't it? Instead of x, I write minus 1 upon 2. Instead of x, I write minus 1 upon 2. 2 and 2 cancels out. So f minus 1 upon 2 equals to minus 1 plus 1 becomes 0. So f minus 1 upon 2 became 0 in this case, isn't it? So option B is the correct answer. We don't need to check this too. Number 3. X minus 1 is a factor of the polynomial fx, but it is not the factor of gx. So x minus 1 will be the factor of fx into gx, or minus fx plus gx, fx minus gx, or fx plus gx whole into gx, isn't it? Let's first understand the question. X minus 1 is a factor of fx. This expression x minus 1 is a factor of fx, okay? But this expression x minus 1 is not the factor of gx. Are you getting me? Yes. X minus 1 is factor of fx, but x minus 1 is not the factor of gx. Now, among these four options, okay, x minus 1 is the factor of which of these four options? We are asked to choose one from these four options. One is the correct one, isn't it? Let me explain you. Let me give you an example to make you understand this. Suppose we have number 6. We know that 6 contains 2 and 3, isn't it? So 2 is also a factor of 6 and 3 is also a factor of 6. So we can say 2 is a factor of 6, isn't it? 2 is a factor of 6 because when we divide 6 by 2, we get the remainder 0, isn't it? So 2 is a factor of 6. Now, let's understand this. We have another number 7, but 7 is not the factor of, 2 is not the factor of 7, isn't it? So when we divide 7 by 2, we don't get remainder 0, isn't it? 2 3 is 6, remainder is 1. So 2 is not the factor of 7, isn't it? So in this case, if we multiply 6 and 7, 6 7 is 42. Is 42 a is 2 a factor of 42? Is 42 a factor of 40? Is 2 a factor of 42? Yes, because when you divide 42 by 2, we get 2 2s are 4, and 2 comes down, 2 1s are 2. So remainder is 0, isn't it? So even though 7 was not the 2 was not the factor of 7, but even then, when we multiply, the product which we got, contains the factor 2. Are you getting me? Yes. But if we add these numbers, now see, let's add up. 6 plus 7, what do we get? 13, isn't it? Is 13 a factor of 2? Definitely not, because when we divide 13, 2 6 are 12, remainder comes 1. So remainder is not 0 in this case. So this is 2 is not the factor of 13, isn't it? When we add or subtract, then we do not get the factor. So in this case, there are 4 options. Among these 4 options, the multiplication option is this one, isn't it? Fx into gx. So this should be the correct option. X minus 1 is the factor of fx into gx. Though x minus 1 is not the factor of gx, but when fx is multiplied with gx, x minus 1 will be the factor of this one. I hope you got this. X plus 1 is a factor of the polynomial x to the power n plus 1 when we are provided with the 4 options. N is a positive odd integer, n is a positive even integer, n is a negative integer. This option is not the correct, because if the power is negative, that expression is not called a polynomial. So power n should never be negative, and n is a positive integer. Among these 3 options, A, B and D, which one is the correct one? Okay, x plus 1 is a factor of this expression. Among these 3 conditions, which one is the correct? Let us check. 0 of the polynomial x plus 1 equal to 0, isn't it? Or x equals to plus 1 becomes minus 1. That means f minus 1 is the remainder, isn't it? F minus 1 is the remainder. So when this is x to the power n plus 1 is divided by x plus 1, the remainder comes f minus 1. And to be a factor, to be the factor of this expression, x plus 1, to become x plus 1, a factor of this expression, remainder f minus 1 should be equal to 0, isn't it? F minus 1 should be equal to 0. So we have this, since let's say fx, okay, fx equal to x to the power n plus 1, or f minus 1 equal to minus 1 whole to the power n plus 1, isn't it? Now, if the power is odd, then this minus will remain minus 1, isn't it? No matter how many times you multiply 1, 1 into 1 is 1, 1 into 1 into 1 is 1, 1 into 1 into 1 into 1 into 1. No matter how many times you multiply 1, you get 1. 1 multiplied n times also gives 1, isn't it? Are you getting me? 1 multiplied 2 times gives 1, 1 multiplied 3 times gives 1, 1 multiplied 10 times gives 1, 1 multiplied 100 times gives 1, 1 multiplied n times also gives 1. Now the topic is the sign, okay? Here we have the power n. If this power n is odd, the sign will remain minus. Then minus 1 plus 1 will become 0, isn't it? So f minus 1 will be 0, the condition will be satisfied. F minus 1 means remainder will be 0. To become x plus 1, a factor of this number, x to the power n plus 1, the remainder f minus 1 should be 0. So to become this remainder should be 0, n should be odd number, isn't it? N should be odd. N should be odd number, odd integer, odd positive integer, isn't it? So if the n was even, the sign would have changed to plus 1. If this power is positive, if n is positive even number, then this minus sign will change to plus 1. And plus 1 becomes plus 2. So f minus 1 will be plus 2, which is not equal to 0. And if the remainder is not equal to 0, that means this expression is not the factor of this expression. To become this expression a factor of this expression, remainder should come 0. And the remainder will come 0 only in the case when n is odd. When n is odd integer, okay? Odd integer, odd positive integer. So in this option, n is positive odd integer number a, isn't it? Even integer is wrong, and n is positive integer is also wrong. N is positive odd integer. If n square minus 1 is a factor of the polynomial this, then which of these four relations, among these four relations, which of one is correct? Okay, since n square minus 1 is factor of this, that means 0 of the polynomial, 0 of the polynomial n square minus 1, n square minus 1 equal to 0, isn't it? Or n square minus 1 square equal to 0. You can say 1 means 1 square. 1 square is 1 1 is 1, isn't it? Or n plus 1 into n minus 1 equals to 0. This means product of these two numbers, n plus 1 into n minus 1 equals to 0, means either n plus 1 is 0 or n minus 1 is equal to 0. If this is 0, then n equal to minus 1, or if this is 0, then n equals to plus 1. So we have two values of n because the power of n is 2, so n values of n is 2, minus 1 and plus 1, isn't it? So to become the factor of this expression, n square by minus 1 to become the factor of this expression, remainder should be equal to 0, isn't it? Let fn equal to a n to the power 4 plus b n cube plus c n square plus d n plus e. Okay, now let's take minus 1. Okay, f minus 1, f minus 1. Since n square minus 1 is a factor, so f minus 1 should be equals to 0. First let me write that. Since n square minus 1 is a factor of this expression, means fn, that means f minus 1. F minus 1 means remainder, f minus 1, isn't it? F minus 1 should be equal to 0. Remainder should be equal to 0. Or fn is this, so f minus 1, therefore f minus 1 equals to, instead of n we write minus 1, okay? A minus 1 whole to the power 4 plus b minus 1 whole cube plus c minus 1 whole square plus d minus 1 plus e, isn't it? Or f minus 1 is 0, isn't it? Remainder should be equal to 0, so that n square minus 1 is the factor of this expression, isn't it? So this is 0, remainder is 0. So since the power is even number, the sign will change to plus. So plus into plus is plus, 1 into 4 is 4, 1 into a is a. Now since the power is odd number, so the sign will remain minus. Minus into plus is minus, b into 1 is b, isn't it? Now the power is even number, so the sign will change to plus. Plus into plus is plus, so c into 1 is c. Now here plus into minus is minus, d into 1 is d plus e, isn't it? Now let's bring this minus b to the left hand side and minus d to the left hand side, plus b and plus d. In the right hand side we have a plus c plus e, isn't it? B plus d equal to a plus c plus e. B plus d equal to a plus c plus e. Option A is the correct answer. I did not take n equal to 1 because if I take n equal to 1, what happens is everything comes plus here, isn't it? Everything comes plus here. So a plus 0 equals to, it comes like this, a plus b plus c plus d plus e, isn't it? If n is 1 plus 1, f1, then 1 1 1 1, everything comes plus out here. That means a plus b plus c plus d equals to 0. It comes like this. So if we change the position, suppose if I bring this a plus b plus e, suppose I'm just giving an example, okay? A plus b plus e to the left hand side, minus a minus b minus e equal to, it becomes c plus d, isn't it? So c plus d should be equal to a plus b plus c but we have minus, isn't it? So this is not the correct option, so we cannot take n equal to 1. Instead of n equal to 1, we should be clever enough to take n equal to minus 1, so that the sign will change and the equation will be fulfilled. Okay, so the correct option is option A. I hope you understood this. Let us calculate and write the value of a for which x plus a will be a factor of the polynomial this. X plus a should be the factor of this expression for what value of a? We are asked to find the value of a. Okay, 0 of the polynomial, 0 of the polynomial x plus a equal to 0, or x equals to plus a becomes minus a, isn't it, when you take to the right hand side. So let fx equals to x cube plus ax square minus 2x plus a minus 12, isn't it? So since x plus a is a factor of fx, therefore f minus a, this is remainder, should be equal to 0, isn't it? So or f minus a equal to, remainder should be 0 to become a factor. F minus a equals to a, instead of x I write minus a whole cube plus a into minus a whole square minus 2 into minus a is x is minus a, isn't it, plus a minus 12. Okay, f minus a is 0, 0 equal to minus a cube. Since the power is odd number, so sign will remain minus a cube. Since the power is even, so this sign will change to plus. Plus into plus is plus. A square into a is a cube. Minus into minus is plus. 2 into a is 2a plus a minus 12. Okay. Now minus a cube plus a cube cancels out, or minus 12 we bring to the left hand side, becomes plus 12 equal to 2a plus a is 3a, or a equal to 12 upon this 3 comes in denominator. 3 by the 3, 3 4 the 12, isn't it? Therefore a equals to 4. Okay, we were asked to find the value of a, and the value of a is 4. A equals to 4. Okay, let us calculate and write the value of k for which x minus 3 will be a factor of the polynomial this. Okay, x minus 3 will be a factor of this expression. For what value of k? For what value of k, x minus 3 will be a factor of this expression. Okay, 0 of the polynomial x minus 3 is x minus 3 equals to 0, or x equals to minus 3. When you take to the right hand side, becomes plus 3, isn't it? So let fx equal to k square x cube minus kx square plus 3kx minus k. Okay, so when this expression is divided by x minus 3, the remainder should be equals to 0, isn't it? So f3, since x minus 3 is a factor of fx, this expression x minus 3 is a factor of this expression, that means therefore we can say f3, that is the remainder, will be equals to 0. Okay, now value of f3 will be equals to, instead of x we write 3. Okay, k square, x means 3 cube minus k, x means 3 square plus 3k, x means 3 minus k. Okay, now the value of f3 is 0 because the remainder should be 0, isn't it? To become a factor, to become x minus 3 a factor of this expression, remainder should be equals to 0. So f3 is 0. K square, 3 cube means 27, 27 k square, isn't it? So we can write 27 k square, 3 square is 9, 9 into k is 9k, minus 9k plus 3 3s are 9k minus k, isn't it? So this minus 9k and plus 9k can be cancelled. Okay, we have 27k square minus k. Let me do here. 27k square, 27k square minus k, isn't it? Minus k equals to 0. 27k square minus k equals to 0. These two are cancelled. Now let us take k common. K, we take k common. K common. Stop writing. K common. So we have 27k minus 1, isn't it, equal to 0. When we take k common, 27k minus 1, k into 27k is 27k square, plus into minus is minus, k into 1 is k, equals to 0. Either product of these two is equals to 0, isn't it? So either k equals to 0, k equals to 0, or either k equals to 0 or this should be equals to 0, or 27k minus 1 should be equals to 0. If this is equals to 0, then 27k equals to minus 1, when we take to the right hand side becomes plus 1, k equals to 1 upon 27. This 27 comes to the denominator. So we have the two values of k. K is either 0 or k is either 1 upon 27. Let us write the value of fx plus f minus x when fx is 2x plus 5. The value of fx is given to us, that is 2x plus 5. We are asked to find what will be the value of fx plus f minus x. Since fx is given to us, fx is 2x plus 5, isn't it? Fx is 2x plus 5. Now let us find f minus x, or f minus x is, instead of x we write minus x. Okay, 2 into x means minus x plus 5 equals to, plus into minus is minus, 2 into x is 2x plus 5. So we have f minus x, this one, and fx, this one, isn't it? So now we are asked to find the value of fx plus f minus x. So fx plus f minus x equals, fx means 2x plus 5, 2x plus 5, isn't it? This is fx. Now f minus x means plus fx plus f minus x. F minus x means minus 2x plus 5, isn't it? So this gives 2x plus 5, plus into minus is minus 2x, plus into plus is plus 5, isn't it? So plus 2x and minus 2x can be cancelled, plus 5 and plus 5 is 10. So we were asked to find the value of fx plus f minus x, and the value is 10. Okay, both x minus 2 and x minus 1 upon 2 are the factors of the polynomial px square plus 5x plus r. Let us calculate and write the relation between p and r. Okay, x minus 2 and x minus 1 upon 2, both of these expressions are factors of this expression, which means when this expression is divided by x minus 2, the remainder becomes 0, and when this expression is divided by x minus 1 upon 2, the remainder becomes 0. Okay, and let's solve this. Let us first solve with this and then with this. Okay, 0 of the polynomial x minus 2, x minus 2 equals to 0, or x equals to minus 2 becomes plus 2 when we take to the right hand side, isn't it? Now let fx equal to px square plus 5x plus r. So since x minus 2 is a factor of fx, isn't it? Condition given to us is x minus 2 and this, both of them are factors of this, so x minus 2 is a factor of fx means this. So remainder f2 will be 0. Remainder f2 will be equals to 0. Therefore remainder f2 will be equals to 0. Now f2 will be equals to, instead of fx we write f2, isn't it? So instead of x we write 2. P into 2 square plus 5 into x means 2 plus r, or f2 means 0, isn't it? We write 0. 2 square is 4. 4 into p is 4p plus 5 2 is 10. 10 plus r. Okay, this is equation 1. 4p plus 10 plus r equals to 0. Let me write this equation somewhere here. 4p plus 10 plus r. 4p plus 10 plus r. 10 plus r equal to 0. This is equation 1. Okay, let me erase this. Now zero of the polynomial this, x minus 1 upon 2 is x minus 1 upon 2 equals to 0, or x equals to 1 upon 2, isn't it? Since let fx equal to px square plus 5x plus r, and since x minus 1 upon 2 is a factor of fx, so therefore remainder f1 upon 2, isn't it? f1 upon 2, remainder f1 upon 2 will be equal to 0, or f1 upon 2 equals to, instead of x we write 1 upon 2. Okay, fx is this, so f1 upon 2 equals to p into 1 upon 2 square plus 5 into 1 upon 2 plus r. Okay, and f1 upon 2 is 0, so we write 0 here, equals to p 1 square is 1, 1 into p is p, 1 square is 1, that 1 into p is p, divided by 2 squared is 4, isn't it? Plus 5 into 1 is 5 upon 2 plus r. This is equation 2. So in equation 1 we have 0 equals to this, in equation 2 we have 0 equals to this, both of this equation equals to 0. This means this equation and this equation are also equal. So please take the screenshot. I am going to erase this. Okay, that means we can say, since this expression equal to 0 and this expression also equal to 0, means this expression equals to this expression, isn't it? 4p, stop writing, 4p plus 10 plus r equals to p upon 4 plus 5 upon 2 plus r. We have 1 here in the denominator. Now let us take the LCM. 4p plus 10 plus r equal to 4, 2 and 1. LCM will be 4. Here comes p plus 2, 2 is a 4, 2 into 5, 10 plus 1 into 4 is 4, 4 into r is 4r. Now let us cross multiply this 4 here. 4 4 is a 16p plus 14 is a 40 plus 4 into r is 4r equal to p plus 10 plus 4r, isn't it? So this plus 4r, if you take to the right hand side, becomes minus 4r, and this minus 4r and plus 4r can be cancelled. So let us cancel here. Now we have 16p plus p, let us bring to the left hand side, becomes minus p. In the right hand side we have 10 let us take this plus 40 to the right hand side, it becomes minus 40, or 16p minus p is 15p, isn't it? 10 minus 40 is minus 30. So our p equals to minus 30 upon 15. That means 15 1 is 15, 15 2 is 30, or p equals to minus 2. We got the value of p. The value of p is minus 2, isn't it? P equals to minus 2. Please take the screenshot. I am going to find the value of r as well. Okay. Putting the value of p in equation 1, putting the value of p in equation 1. Equation 1, we have 4p plus 10 plus r equal to 0, or 4 into p is minus 2, isn't it? P is minus 2 plus 10 plus r equal to 0. Now 4 to the 8, minus 8 plus 10 plus r equal to 0, or minus 8 plus 10 is 10 minus 8 is 2 plus 2, isn't it? Plus r equal to 0, or r equals to plus 2. When you take to the right hand side, becomes minus 2. So we got the value of r equals to minus 2, and value of p is also minus 2. Therefore we can write the relation between p and r is p equal to r, because the value of p is minus 2 and the value of r is also minus 2. Then we can write p equals to r. Okay, I hope you understood this. Now let's move to the last question. Question number 5 of 12. Let us write the 0 of the linear polynomial fx equals to 2x plus 3. Okay, 0 of the polynomial. 0 of polynomial fx. Fx should be equals to 0, isn't it? So this means 2x plus 3 should be equals to 0, or 2x equals to plus 3, when we take to the left hand side becomes minus 3, or x equals to minus 3 upon this 2 comes in the denominator. X equals to minus 3 upon 2. Okay, this was the last question from this exercise. We have completed each and every question right from exercise 7.1 to 7.4. We have completed each and every question of the chapter called polynomial. I hope you understood the concept of polynomial. Thank you so much for watching this video. Stay connected, stay blessed, stay happy, okay? And don't forget to subscribe and click the bell icon to get notifications for more video uploads. Thank you.